everyone. Today I just wanted to briefly go over what we went over in the daily last week. I give you an arbitrary function with a lot of things going on with open and closed dots and things like that. And then I ask you about limits and values, and I expect you to know what they are. So I just want to go over them really quickly. Um, okay, so the first thing I want to ask you is, what is the limit of the function as x approaches -1 from the left? Okay, so immediately my eyes go to whatever x is approaching, and x is approaching -1 in this case. So I look at the line x equals -1, and if it helps you, you can make a little dashed line to indicate x equals -1. Okay, so it's approaching from the left. That means that I'm looking at this side of the graph. If we're using this line kind of as the origin here, I'm looking at this side here from the left. And I look at the branch of the function on that side that's approaching -1. And it looks like it's this branch, right? It's approaching -1 from the left. And once I get to -1, once I get to that line, x equals -1, I stop, right? Open or close dot, I just stop right there. And then I look at that corresponding y value wherever x is approaching, right? And it looks like we have -2 here. So that's what I'm going to put for our answer. Okay, so now we want to know what the limit of the function is when x is approaching -1 from the right. So same thing, but now we're looking from the right side, right? And we're looking at the branch of the function that starts from the right side and approaches -1. So I'm going to be going this way. And once I get to -1, I stop. And it looks like, again, that corresponding y value of wherever we stopped is -2. Okay, so now if I know that the left-hand limit and the right-hand limit are the same values, if they're both -2, for instance, then I can say that the limit of the function as x approaches -1 is also -2, right? Okay. Another thing I wanted to point out is even if you have a limit, like right here, even if it's going to -2, x is approaching, actually the limit is -2 as x is approaching -1, it doesn't necessarily mean that the value is -2 at x equals -1, right? It doesn't necessarily mean that f of -1 is -2. Because we have an open circle here, actually, we know that that's not the case. The value of f of -1 is actually up here where this closed dot is. It's actually -1. In other words, when x is -1, y is -1, right? And that's indicated by that closed dot. I just want to make sure that everybody sees that distinction there. Now, if this dot had been closed and there was no closed dot up here, then yeah, we could say that the value f of -1 should be -2. But it's not. We have an open value here. The real value is actually up here. Okay. So now let's move over to the other side of the graph. What's the limit of the function as x approaches 2 from the left? Again, I'm going to look at the line x equals 2 and draw my little line here dashed. Kind of gives me an indication of where everything's at. And it looks like we're approaching 2 from the left. So again, I'm going to look on the left side of that line, okay? And look at the branch of the function that's approaching that line from the left. And it looks like it's this branch. And now we look for the corresponding y value. Looks like it's 3. The y value is 3 right there. Now if we're approaching from the right, same thing, but now we're going from the right side, okay? And we're approaching that line from the right side. And it looks like that y value is 2. Okay. Now this is a little different. Because the left-hand limit and the right-hand limit are not equal to each other, because 3 is not equal to 2, then we can say that the limit of the function as x approaches 2 does not exist. Okay? So I hope that cleared a few things up. If you were having any questions or concerns about that, I hope you have a good day. Thanks for watching.